Right. I'll continue the session. Hope that you can see my screen.
Yes,
Right.
sir.
Yeah, fine. Okay. So, in very nutshell, I'll just summarize that we learned last time. So I just a small recap because we need to continue. So I just do a small recap how we have learned and what did we learn. So we were talking about the normalization process. Okay. So here we learned about some what is that dependencies. I hope you can understand. So functional dependency we were talking about, then partial dependency we were, the next one is transitive dependency. These three dependencies if you can understand, then everything fine. Functional dependency, so simply we can say functionally depending on particular candidate key in the sense, especially we can say that is a key, prime key. Okay, so if you take this one, um, for example, B is functionally depending on A, we set the word determinant, and B dependent. So we have learned this part. So if I say one relation is in one NF, so the multi-value attribute must be removed. Multi-value attributes is removed. How we can see the multi-value attribute? That you can find direct or indirectly the attributes depends on primary key. If you find this case, then simply you can see there is no multi-value attribute. Suppose if you can't find this case, definitely you can say there is a multi-value attribute. Say for example, I'll call this one. In the previous case, last time we learned about this one. I'll call the same example. Say we have one relation A, B, C, D, E, right? B is depending and C is depending. Uh, E is depending on D. So if you take this case, if you take this case, then what will happen? So we can write this one like A, B, C, D, E. So you can see B is depending on uh, B is depending on A, and C is also depending on A. Then E is depending on E. Now you can see this B and C depends on the primary key, but the D and E not depends. Depends mean either directly or else indirectly. It is not depending on the primary key. So we can say there's a possibility to find multi-value attribute. So because of this case, multi-value attributes can be found. But here you can see directly the B and C depending on A. D and E is not depending on either directly or else indirectly. So if you say one the relation is 1NF, so no multi-value attribute must be existing. No multi-value attribute must be existing. So you must be careful on this case. So if you say this relation R1, you can simply say this is 0NF, because you can see multi-value attribute is there. So simply we can say this is 0NF. Okay, so the functional dependency story is that. The second stage we have gone through uh, partial dependency. Partial dependency, it is always happen. It always happen because of the combination. So this one, the combination of the keys. So if you find only like this, there will be no partial dependency. If you find this one like this, then possibility. So we can't say always, but we can say there is a possibility, to existence of partial dependency. So that is also we learned. So I'll just do some recap. Say A, B, C, D, E. Okay, so A and B uh, primary key, that is a composite primary key. C, D, and the E is depending on B. Now you can see. So if you take the C, it depends on A comma B. So no problem. Fully depending, A and B, fully depending. If you take the D, fully depending A and B. If you take the E, it depends only on B. So B is a partial key. So the primary key is A and B, but the only, if you take only B, it is a partial key. So we are telling the E is partially depending on B. So because B is a partial key, A and B, that is a primary key as a composite one. B is partial. So we learned this also last time, the partial dependency. Next one, I hope that you understood the partial dependency. Yeah, right, fine. Uh, the next one is transitive dependency. So we all know about this transitive dependency. So the transitive dependency, you can see a non key depends on another non key. This is a non key. This one is a non key. Depends on another non key here. So this situation we are calling as TD, transitive dependency. So we will see one example for that, so you can easily understand. Say B, C, D, E. Okay, so hope A is primary key, B is depending, C is depending on B, D is okay. Uh, right. So now you can see, if you take this case, B is depending on A. Functional dependency, no problem. Functional dependency, no problem. Uh, Give me a second. Okay. So I'll continue here. B is depending on A. It is functionally, we can see, as well as you can see C is depending on B. B is depending on A, because you can say this is indirectly depends on primary key indirectly. Now you can see D also depend on B, so that is also indirect functional dependency, right? Then E depends on D. E depends on D. So that is also, you can see, indirectly depend on primary key. So that is why so we can say as that is functional dependency, fine. But now we are just talking about the transitive dependency. Transitive dependency, one non key depends on another non key. If you see this case, then simply we can see that is the transitive dependency. Now you can see the B and C, case this case B and C. Fine. Now okay, no? Right. So I stop sharing the for the time. Okay. Now okay, I hope. Right. Now in this case you can see, so in any case, if something wrong, please just forward me the messages, okay? Or else you can just unmute the microphone and you can tell. Right. um okay, now if you find the case like this, AB, that is fine. AB is fine, because it is depending on this primary key. BC, this is a non key. C is a non key. Now a non key depends on another non key. Now if you take the D, it depends on B, this case. So again, this D depends on B. This D depends on B. B is a non key, and D also a non key. So again, you can see this case D and E. You can see D and E. This is also a non key. This is also a non key. So a non, if you find a non key depends on another non key, we can say there is a transitive dependency. So now we can go with we learned about this functional dependency. The second one is partial dependency. Third one, transitive dependency. Okay, transitive dependency. We learned all these three now. Now, in a nutshell, I'm going to do one small um, chain here. Now, my table is in 0NF. It should be, sorry, it should move to 1NF. It should move to 2NF. Then it should end in 3NF. Okay. Now, we have some certain processes already we learned about. We are removing of multi-value attribute. Then 1NF to 2NF, we are removing partial dependency. 2NF to 3NF, we are removing transitive dependency. Transitive dependency. So this is a set of processes removing multi-value attribute here, removing partial dependency here, removing transitive dependency here. Okay, now we'll do one small example, right? My relation one, I have A, B, C, D, E, F, right? I have the right. Okay, this is my question. So I want to prove whether this particular relation one is in which normal form, right? This is my question. So it is in which normal form that this particular relation is, right? Now you know everything about this conversion is in the sense how it is being to identify this one. So first of all, um, you have to check the multi-value attribute. Check the multi-value attribute, right? Rather than going like this, right? If you check the functional dependency in a proper way, then you can check this one. Okay, right. Now I am going to draw a small diagram. It is which is very easy to find all these things. Okay, now this A, B, C, D, E, F, I have A, B, C, D, E, and F. So you can see they are functionally depending on this one, B, C, D, E. So I'm the simply I can draw the B is depending on A, C is depending on A, D is depending on A, E is depending on A. So you can draw simply these arrows, and the next one, this is the first one, this is the second one. F is depending on B, right? So now we know about the dependency. Now you can see this screen. Simply I can say whether this is a primary key. Okay, oh my, if all the arrows are other way around. Okay, right. No one told this, eh? I just drove all the arrows, but no one told. I put reverse arrows, right? Okay, only this arrow is right. So now you can see my primary key A, the B, C, D, E, all are Simply I can say directly. Directly depend on the primary key. F, you can see F indirectly. So you can see this is the case. So the F is indirectly depending on A. So all the attributes, say B, C, D, E, and F, all the attributes are either directly or indirectly depends on A. So I can say everything depends on A. So I can simply say this relation uh, is at least in one NF. It means first normal form. So if you say this is first normal form, you should not find any multi-value attributes. Okay, so that is the first stage you have to do. Now I want to check whether this particular table, sorry, relation is in second normal form, right? You know second normal form, especially from 1NF to where you can see this is, I have wrote something where one, right, you can see this one. So here the second normal form, if you want to identify this one, you have to check the partial dependency. If you find partial dependency, you have to remove that. So here you can see, do you have any partial dependency? Partial dependency, if you say this partial dependency, where you can find the partial dependency is if you find any composite primary keys. So now it is clear that it is clear that now you can see it is clear that I have only one primary key. So if I have only one primary key, simply you can write there is no composite uh, keys or primary keys. So there is no partial dependency, right? So if there is no partial dependency, this relation is at least second normal form. Why we are using the word at least is sometimes this form may be in the third normal form. So we can't say exactly. That is why we are writing like that. Right. Now I am going to check for the third option. What is this? Is whether this particular form is third normal form or not. Right. Now third normal form mean if you find this is third normal form, if you say a relation is in third normal form, first of all it must in second normal form, because from the second NF to 3NF, so from the second NF only the third NF coming. So if you say this is the third in normal form, definitely there must be the particular form must be second in. So second point is there is no transitive dependency, because from the second to third we are removing the transitive dependency. So you can, these 2 points must be checked, important, right? Now if you take the first one, if you take the first one, the relation, so transitive dependency is there. You can see here B is a non-key attribute, F is non-key attribute. So the F is depending on B. So the, I'm going to write. So clearly you know now F is depending on B. B is not a primary key. So a non key is depending on another non key. Now you can see, since there is transitive dependency, inside the bracket you can say uh, transitive dependency, the form is not in third normal form. Then you can write, therefore this particular or else this relation is in second normal form. Here you don't write, you don't write like at least second normal form. No, because you have confirmed now. Because I don't have, because I can find the transitive dependency here. So my relation must be, is, must be, or else my relation is in second normal form. So now it is damn clear to prove this one. So in your exam paper, definitely you will find the questions like this. Definitely you can, um, you will have, right? Now I am going to have another example, right? Example 2. Say B is depending, C is depending, D is depending, mm, uh, K, L. So now I want to check with this is whether 1NF or not. If I want to check whether this is 1NF, check the, I need to check the multi-value attribute, right? Multi-value attribute, the primary, the attribute directly or indirectly depends on the primary key, all the attributes, right? We will check. So for, before that we can, if we write the all these things, it is easy, right? Now you can see B C D depends on A, B C D. K is depending on C, K depending on C, L is depending on K, right? Simply in the first look you can see this is no, not a third normal form. Why? You can find the transitive dependency. Simply in first look you can see. In the first look you can see this will not be the third normal form because transitive dependency you can find, right? Now can be second normal form, can be, because it is, there is only A is a primary key, there is no partial dependency. Since only one primary key, there is no composite, so you will not find any partial dependency. So you can say sometime this particular relation maybe, you can think this maybe second normal form, but damn sure it is not third normal form because this K L, this the KL, you can see transitive dependency, right? Now step by step we'll see, right? So you can see BCD directly depending on A, functionally depending, directly depending on A. Now K is depending on C, it means K is indirectly depending on primary key. The L is depending on K, so the L is indirectly depending on A. Now you can see all the right. Okay, before that I'm right. Okay, fine. Then I'll go with a very simple one, right? So the specifically we have to think about the dependency. The dependency is always easy, right? Some students think maybe I'm really fast to understand, right? So because this is already we learned last time, that is why I I've been a bit fast, right? So I'll go slowly, then you can understand, right? So mm, right. So that is very fair call that to explain between Sinhala and Tamil. But only the thing is, if I start to explain those in two languages, um, it eats more time. So let's first finish this one, then I'll go with the different languages. Okay, right. So try to understand. I'm just going in a very simple manner, right? So hope that you will understand, don't worry, right? By the time definitely you will understand. So in this case um, all the attributes, this one, B, C, D, K, L, all the attributes somehow depending on this primary key. Somehow, why I'm using somehow? The BCD directly depending, see, AB, AC, this BCD directly depending on A. K directly depending on C. C is depending on A. K depending on C. C is depending on A. So this K, uh, we can say K is indirectly depending on A. Indirectly. The same story. L is L is directly depending on K. K is depending on C. C is depending on A. Right? It is look like this. A, C, K, L. Now you can see this L somehow, the L somehow, see the chain is proper, chain is, it is not broken, it is proper chain, A, C, K, L. So this L is somehow, it depends on A. That is why we can say all these attributes are depending on A. A is a primary key. So if all the attributes are depending on A, we can say no multi-value attributes are existing. So this relation is at least one in first normal form. At least. අපිට දන්නේ නැහැ whether this is second normal form or third normal form. Sorry, second normal form අපිට දන්නේ නැහැ නේ තාම. ඒ හින්දා අපි use කරන්නේ at least. The word at least we are using. Okay. So now we have come for the conclusion that our relation is at least in first normal form. Now we need to check for the second normal form. It is simple, no, second normal form, because if you want to check the second normal form, you have to check the composite primary key. Now you can clearly see I don't have any composite primary key here, single primary key A. So simply I can say there is no partial dependency. If no partial dependency, then the relation is at least in second normal form. So uh, now we know that this relation is in second normal form, right? Third, now we have to think about the third normal form. Third normal form, it is not necessary to even think. You know why? We can find this K and L. L is depending on K. This is K is a non key. L is a non key. So the L is depending on K. So non key depending on another non key. So there is transitive dependency. Okay. So we can simply say, since there is transitive dependency, you can say like this. You can show like this. L is depending on K. Since there is a transitive dependency, then it is not third normal form. If it is not the third normal form, then we can conclude our story. We can conclude our story. Therefore, this relation in second normal form. Right. It is very simple. Definitely, you will, get the questions like that. So I'm doing more examples, then you will understand. Okay, I'll go for the third example. So in this example, I'm rather than in writing like that directly, I just go with the drawings directly. Okay, right, right. Mm, Lakmal Prasanna, yeah, just mute your mic. Lakmal Prasanna, mute your mic. Right. Now we will go for the third example. Right. Now, students, you can clearly see. Now, with the third example, you must be little expert on, you know, taking decision, right? Without writing anything, we can have some assumption kind of decisions, right? So not in writing, but in assumption, right? You can write some, you can take some decisions. See the first decision. It is not 3NF. It is not 3NF. It is not 3NF. Definitely, you can simply take this decision, right? So I'll call upon Nipun Shanaka. Please unmute your mic. Nipun Shanaka. Nipun Shanaka. Nipun Shanaka, you are there? You are there? So if you are not there, then I'll remove you. Okay. So I'll call um, Ruant, ICT 016, Ruant, ICT 016, Ruant, unmute. How come? Right, I'll call Kaushalya Kanchana. Just come to the stage, unmute your mic.
Yes, sir.
Okay, good. So Kanchana, I have a couple of questions to you. Um, by looking this relation, I'm telling it is not in 3NF. Why?
Mm, it has transitive dependency.
Exactly, very good. So simply you can decide, if you find any transitive dependency, you can say it is not in third normal form. Okay. Now another question, that can you guess whether in this particular relation, can you guess whether is there any partial dependency possibility? I'm not
Yes,
exactly asking possibility. Any
yes,
partial dependency possibility?
yes, sir.
Yes. Why you are telling this?
Mm,
Why you are telling there is partial dependency?
mm.
Very simple answer. Just you can see and tell.
It has non-key.
No, partial dependency. Yes, it has none key. Okay. Partial dependency. We don't talk more and more about the none key. None key we are talking. We especially we talk none key during the transitive dependency. So in the partial dependency, we talk more and more composite
Composite primary.
primary key. If you find any composite primary key like this A and B, C, then you can think, not exactly, right? You can think there might be a, maybe, the particular relation, in the particular relation, there may be some, uh, what is that? Partial dependency. Okay. Mute your microphone. Right. So simply we have to take the decision while just looking your relation. So simply you can decide, you can see this one, transitive dependency. Simply you can understand this transitive dependency. So simply you can say it is not in third normal form. So if you see this case, it means composite key. Then there may be a possibility to have the partial dependency. If you find only composite primary key, then only we can say, okay, there may be a partial dependency. So we need to check further. So if you say only the A is a primary key, then there you don't need to think about the partial dependency more than then this it is not composite one. It is a tiny primary key. So it is easy. If you find any tiny primary key, then you don't need to think about the partial dependency. But if you find a question like this, composed one, then there may be a chance to occur the partial dependency. Okay, now you can see in this question, we can decide this is not third normal form because of this case. Okay, not, it is not third normal form. Right, now we can see C depends on A comma B. It is totally depending. So the our primary key is AB. The C is totally depending on AB. D totally depending on AB. E depends on only B. Only B. This is the case. Only B. Here you can see partial dependency because our primary key we know A and B. So we can't say A is a primary key, B is a primary key. That is the strong primary key because it is a composed one. So if you say only A, then something depending on here, that is also partial dependency. Some depends on the B, that is also partial dependency. If it is depending something depending on like this, then you can say obviously this K is good. That is totally depending on our primary key, right? In this case this question, the E is depending only on B, not the whole primary key. So now you can say there is a partial dependency. Now you can simply decide if there is partial dependency, then it is not second normal form. So simply you can say, right, this is not second normal form because the E is depending only on the B. Now third normal form, no. Second normal form, no. Then obviously that is 1NF because F, E, D, C somehow depending on the primary key, right? Now you can see E. Now there is another question you may ask. So this question sometime you may ask whether how we can say this E is depending on the primary key. So that our main case is somehow we need to other attributes somehow depend on the primary key. So now you may ask why simply E can be taken as it is not completely depending on primary key, no. So it is important that if you find the primary key like this, ABCD composite primary key, uh, E is there, it is depending only the D, then that is done. No problem. No problem. Right? Somehow you must connect that one. So you can see it is connecting like this. B, uh, E, F. It is connecting like this. So B is part of primary key. For the functional dependency, so we don't bother. No problem. No problem. So you have, if you take A, B, C, D is a composite primary key, my this F or else some letter only depending on this one, partial dependency, no problem. No problem. That is for the functional dependency functional dependency, we don't bother about the partial dependency. Somehow all the attributes should be connected with the primary key. D or else B, here the D or else here the E or something, depending on the B, that is partially it is depending. Somehow it is depending. Partially it is depending. So that is, we don't have any question on that, right? So don't worry, the answer is right. So if you say like this, uh, then if I ask whether this is first normal form, I'm telling okay this is 1NF. Then why I tell this one normal form, first normal form mean, simply you can say the C is depending fully, no worries. But D, it is depending only the B, only the B. So no problem. So it is functionally depending, but that is partial dependency. Partial dependency we don't talk in the first normal form. So 0 to 1, we don't talk about the partial dependency. Here we talk about the functional dependency only. So you don't need to check the partial dependency there. So if you want to go to 1 to 2 only, here partial dependency I will check. 2 to 3, I will check the transitive dependency. Okay, so here it is no worries. If you partially it is depending on B, so we can simply say this is 1NF. It is 1NF. Simply you can say it is at least in 1NF. So now simply you can say the D, B, it is depending only B. So you can find there is a partial dependency. If you find partial dependency, it is not second normal form. So it is first normal form. Simply we can conclude the case. Um, shall I go for uh, some more example? Are you okay with doing more example? If I go with more example, will it be useful to you? Yeah, no one is responding. Fine. Example 4. So this time I'm writing like this. Okay, B, C, D, E, F is depending on G. Now this is the example. So I'm asking whether this particular relation or this particular relation is in which normal form. I'm asking this question to you. Okay, now I want to check whether this particular uh, relation in which normal form. Right now I'm going to draw this one. If you draw, it is easy. So I'm telling here is a primary key depending on B, then C, D, E, all are depends on B. Then G, F is depending on G, right? So we need to check whether which normal form it is. Now you can see B, B, C, D, E. All are directly depending on the primary key. C, B, C, D, E. All are directly depending on the primary key. So if it is depending on the primary key, no problem. This is functionally depending on primary key. What about this G? What about this G and this F? G and F. So you can't find any connection between this one. See, A, B, C, D, E. If you find any like this only, we can have the connection. But you can see here G, F is depending on G. G is not depending on anything. G is not depending on anything. So there is multi-value attribute, right? If you find any multi-value attribute, if there is multi-value attribute, then the relation is not in 1NF. Someone acknowledge me whether can you hear me?